Hey everybody, this is Mr. Mathblog here. This lesson is we're graphing data. We're going to graph some ordered pairs. This is 9.3 in our textbook. Don't forget all your lessons can be found at mrmathblog.com. And if you guys can, if you find these videos helpful, please click like, and it just kind of helps encourage me to keep going with this. All right, let's get started here. So there's our Common Core strand, and our question is, how can we use a coordinate grid to display data collected in an experiment? Okay, so let's get started here. So below is a table for the noon temperatures taken each hour after noon. Did I say noon temperatures? Below is a table for the temperature taken each hour after noon. So after 12 o'clock in the afternoon. Okay, that's what that means right there. So the first hour is 61 degrees, the third hour is 65 degrees, and so you'll notice right here, this is our x-axis right here. So typically if you see a table that's written like this, the top row is your x-axis and the bottom row is your y-axis. Remember, x, y comes in alphabetical order, so you just kind of do the same as this. This is first, so this would be second. So this would be, since x comes before y in the alphabet, then the first set of numbers is typically our x's, and the second set of numbers is typically our y's. All right, so it says write the ordered pairs for each point. Okay, so this is going to be x comma y, so 1 comma 61, 3 comma 65, 5 comma 71, and those other 2 points right there. So there they are right there, and then we're going to go ahead and graph the data in a coordinate grid. Okay, so here we're going to graph this guy first. So we're going to go, this is our x, so this is going to be over. So we're going to go over that 1 and then up 61. Okay, well 61 is going to be a little bit past 60. So it's going to be like right about there. Okay, so remember we go over and then up. Okay, so for this one we're going to go, we always start at the origin. So we're going to go back to the origin right here. And this one says go over 3 up 65. So we're going to go over 3 and then up 65. So that's going to take us right in the middle of 60 and 70. So right about there, okay? So there's that one right there, okay? Over 5 up 71, so just a little bit past 71. Almost looks like if we connected them it would be a straight line. It's not quite a straight line, but it's pretty close. Okay, then this next one here is going to be over 7 up 75. So over 7 up 75 right there. Okay, all right, so there's that one, and then finally over 9 up 97. Now I can see that one's not quite on the same path as these ones right here. So it still did go up, but it only went up 2 degrees right there. Okay, so how would the ordered pairs be different if the outdoor temperature were recorded every hour for 5 consecutive hours? Well, let's look right here. This is being recorded every 2 hours. 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. So if we went up every hour, then this would be 1, and then this would be 2, and 3 would be right here. So this 365 would actually go right here. This would be 4 comma something and 5 comma something. Okay, now what would happen here, you guys, is since we're going up in 1 hour instead of 2 hours, this is what it's asking, it's going to go up about half, because 1 is about half of 2. I don't know if you can hear my fireplace crackling in the background right there. It's a cold winter night right now, and it's raining outside. Anyway, so since these are going up by 2, instead of going up by 2, we go up by 1, which is half of that. So we'd go up half of this distance. So from 61 to 65, that is 4 right there. So if we go up, half of that, that would only go up to 2. Okay, so it would be 63 right there. Okay, and let me just slide that up right there. Okay, so since these temperatures were recorded every 2 hours, recording every 1 hour would be about half the difference. Okay, so instead of going up 4 right there, we go up 2. So 61 plus 2. So here's the first point. It's the same as that first point right there. Notice the third point is the same as 3 hours right here. And notice the 5th hour is the same as this 5th hour right here. But instead of going up by 4, we go up by 2. So 61 plus 2 is 63. Okay, this one was already given, so let's look between 3 and 5. Okay, so between 3 and 5, it also went up by 2. So if we went from 3 hours to 4 hours, I'm sorry, did I say 2? Up by 4. We'd go up by 2 from 3 hours to 4 hours. So from 3 hours to 4 hours, we just add 2 to that. Okay, and then this one was already given right here, 5,71. Okay, so you just got to kind of glance and see what's happening. If you couldn't see that, sometimes you can't see that. I just slid that up right there. Okay, here's another one here. So we're going to make a graph of this data on a coordinate grid. Okay, now this is going vertical right here. Some couple of big cracks in the background there. So just like the last one, this is the first set of numbers. So what do you think this is going to be, the x or the y's? Well, x comes before y in the alphabet, so this is going to be our x values, and this is going to be our y values right here. Okay, so Jack places a miniature car onto a track with launchers. Okay, so the speed of the car is then recorded every foot. Some of the data is shown in the table. Make the graph of his data. Okay. So imagine, he shoots these cars in these launchers, and they start off really, really, really fast, and then they start slowing down, and sooner or later it's going to come to a stop, so the speed will be at 0 again. But that's why it says some of the data right here. Okay, let me slide that up so we can play around with that there. Okay, so first thing we've got to do is make our axes, our x and y axes. Okay, and always the horizontal is our x axis and the vertical is our y axis. Okay, remember x comes before y in the alphabet, so these will represent our x numbers. These will represent our y numbers. So 0, 0, 1, 4, 2, 8. All right, but before we do that, we always have to label everything. So let's give a title for our graph. So here's the title for our graph. It's right here. It's usually right here, somewhere around the table or inside the table. So miniature car speed right here. Okay, and then this is our speed right here. That's the right column right here, our speed in miles per hour. If you can tilt your head sideways, I'm looking sideways right there. And then down here, this is our distance. That's from this x column, our distance in feet. All right, so then now we're going to go ahead and start graphing these points. So let's plot the points. So we're going to go ahead and plot 0, 0. Okay, there's 0, 0 right there. And then we're going to go ahead and plot 1, 4. So over 1, up 4 from the origin. Okay, so over 1, up 4. Okay, so there we go. And then we'll go over 2, up 8. Okay, you guys get the hang of this. This is easy, huh? Over 3, up 6, and then over 4, up 3. Okay, it's that easy, guys. Just make sure that this is your x, unless otherwise stated. Sometimes they might make you switch it and make this the x, but they'll specifically state it. And if they don't, assume this is our x column and this is our y column. And when you had a table where the numbers were going on top of each other like this in a row, then the top row would be your x and the bottom row would be your y right there. Okay. All right. One more question here. What do you think? Why do you think that speed went up and then it went back down? Well, we talked about the launch. So as the car is launched, like shooting a rubber band, it picks up speed and then it comes to a stop. So it starts off going fast and then it goes slower right there. Okay, you guys, if this video was helpful, I would appreciate if you can click like, and I hope you're having a fantastic year. Take care.